That sucks. Oh well. Both suck a little bit. Alright, poor little dude. Alright, let me just do a couple of the first ones, right? First couple. Just make sure we're all on the same track. That number one should not be any problem. This is back from like Math 90. You have 40 feet of fencing to enclose a rectangular space, right? The area of the space as a function of width. So what that means is I want a formula area equals, and there's only W in it, or only whatever letter I want to represent width, right? Let me put this one on the better projector. There you go, buddy. So what does that 40 feet of fencing tell me? Can you draw this thing? So let's see. Yeah, it's the perimeter, right? So what am I going to label here? I got WL, WL. So I often call this tell me, ask me. This should be very familiar. 176, you did optimization problems, where you had to write an equation. It ended up being quadratic. You used negative b over 2a to figure out the max or the min. So the max profit, the minimum cost, max area, whatever. Does that sound at all familiar? Hopefully, or else, again, go slap your pre-calc teacher. So what can I write based on this and the first piece of information? They tell me what? That there's 40 feet of fencing. So how do I write that into an equation? Yes, 2L plus 2W equals 40. Perimeter equals perimeter. That's amazing. What do they ask me? Area. So what's the function? What's the function for that one? L times W. I love it. Can you use what they tell me to rewrite what they ask me? And here I'm being very specific. I want the width to show up. So can I use what they tell me to help me rewrite what they ask me? What do I do specifically? Solve for L, because I want to replace L with W stuff. I want the L to disappear. So this is very, remember elimination method where you just multiply and made a variable just die directly? This is that subversive substitution where you sort of like replace invasion of the body snatchers kind of thing. So if I solve this for L, what do I get? I can divide everything by 2. That kicks ass. Look for that shit. And so L equals 20 minus W. So wherever I see L in this guy's universe, I can replace it with 20 minus W. So what's the area become? Yeah, 20 minus W times W, or 20W minus W squared. And see, that's the end of what I want. But in pre-calc, and of course for us we're going to go even further because we're insane, it would have asked you what's the maximum area. Why would there be a max area instead of a min area? What is it about this that tells you there would be a max area? Yeah, parabola opens down. So it's got a top to it, right? And how would you find that maximum area? Where would that occur? At the vertex. And what was the shortcut to find the vertex back in the day? Negative b over 2a. We actually saw the calculus proof of that. It's a lot quicker because calculus is a lot more powerful. Beautiful. So that's the way you would have done it in pre-calc. Now we're going to get stuff that's not just quadratic. But it's the same idea. Where is the tangent line horizontal would be the location possibly of a max or a min. Right? Okay, that's actually what we're going to do. Calculus optimization happens in chapter 4. But this idea of rewriting functions, because there's too many freaking variables here. I don't know if you guys realize the title of this course is Single Variable Calculus. Calc 3 is multivariable calculus. So you deal with functions with a lot of variables. We won't do that yet. Okay, so that's the end of that question. What about this guy? Where's a good first step? What's a good first step? What's the first step we did on that funky-ass problem we did first in the classroom?
Visualize it?
Yes, visualize. So I want a rectangular container with a square base. So I don't know if you guys, how you know how to make 3D. Hopefully you know some way. Square base length X. Can you take a minute, first off, draw that sucker. Now label it correctly. The base is what shape? Base length X. So what goes here? And what goes here? X, because it's square base, right? Don't bring in more variables than you need, because that sucks. But what's this? H. I love it. Now, just like this first problem, the volume. Now, be careful. You've got to be a little careful. What do they tell me? What do they ask me? What do they tell me? When I say that, I mean specifically, what do they tell you? They tell you something specific. So far, the X's and H's, yay. Right? But what do they tell me, for sure?
The volume of the container.
No. Careful. What's the units on this sucker?
The surface area.
It's the surface area. I want to construct it from so many square feet, so much square feet of material. That's going to be the surface area. What they asked me about is the volume. Let's write this one first. What's the volume of this bad boy?
X squared times H.
X squared times H. Too many variables. Too many variables. Only single variable calculus. So thankfully they're going to tell me something that helps me rewrite what they want me to work with. Can you?
Yeah.
Thanks, man. Sorry. It's going to slowly drive me insane. More insane. So what is it? So again, this is funny. Never memorize any perimeter formulas. You already know 2W plus 2L, and that's bad. Perimeter is silly to memorize. Surface area is a type of perimeter, if you really think about it. How do I get the surface area of this bad boy? What's the area of this side? And how many of them are there? 4 XH's. And what's about the top and the bottom?
Together it's 2x squared.
Yeah, x squared each, so plus 2x squared. And that's supposed to equal? 1,000. So that 1,000 square feet is going to go into making 4 sides and a top and a bottom. That's how to look at that equation physically. Can I use... Now, what is it asking me to do, right? The volume as a function of x. So, of course, which letter do I want to get rid of? H. I want to get rid of H. So then what do I solve this one for? I'll solve this one for H, because then I can put a function of x in place of H, and then my volume will end up having only x in it. So if I solve this sucker for H, 1,000 minus the 2x squared divided by the 4x that I don't want, and I just plug this sucker in for H. Oh, you look better over there. All right. Poor little dude. How are we doing? No? Yes? Not really? Yeah? Okay. Really not difficult, especially if you allow yourself to organize the problem. Tell me, ask me. I love that. I've been teaching it that way forever. And until somebody shows me a better way, I'll keep doing. So you guys try the next couple. Is everybody cool with that? Let me just make this all official. This would be, if I plug this H in, do you see how one of the X's cancels? Is that cool? So then this will be 1,000 x minus 2x cubed over 4. Because that x cancels with that one of those x's. So try to do 3 and 4. And really nice, I gave you the volume formula for cylinder. I like this room. You guys must like extra space, right? Yeah. Sending it I am neutral. Okay. Yeah, number 3 is a little bit different, but you set it up the same way.